Geoff Korfin with Rensys.
So good morning, everyone. I'd like to thank you for showing up today. My name's Geoff Korfin. I've been working in the transportation sector for about 14 years, developing products and solutions that I really think are innovative. It's a father-son team. My father, Art's right in the back of the room. We work nicely together. So today I'm going to be discussing Rensys, which is a structural health monitoring tool, and I'm going to be discussing more its use as an asset management tool and how that's being used and implemented around the country and around the world. The real genius behind the Rensys system is really found in the SenseBot sensor technology itself. It's fully wireless, small footprint, about 2 inches by 2 inches, can be installed in 1 to 2 minutes. Battery life is 20-year design, 10-year minimum guaranteed. It's fully weatherproof, IP65, so it can actually even be submerged in water, taken out, and it's still going to work. Each sensor transmits 4 data points. The sensor data, the temperature, which is essential for whatever you're monitoring, battery life, and connectivity. So as soon as a sensor, should it ever go down, we don't usually have that happen, you can know and get out to the field and replace it. So how Rensys works. So you're going to put your sensors out on the structure at key points identified. That data is going to go to a gateway, which is solar powered. It's about 1.5 feet by 1 foot, small footprint. It has a backup battery for 60 days. So should you be short on sunshine or need power, it has a backup, and it also backs up the data. It can also be connected directly over Ethernet or fiber optic should you have it. That then goes to a cloud server, an Amazon S3 cloud server, and can be transmitted to the SenseScope software. The data can also be pulled directly from the server should you want to use it in your own program or interpret it differently. The Rensys system is highly reliable. From the data in the field that we have, it's 99.9% readily available. There's a wide spectrum of sensing features. You can do strain, tilt, inclination, displacement, vibration. It's a cloud-based data management system with real-time automated detection. So rather than give you hundreds of alerts that you really don't want, the software uses AI and algorithms to identify the normal movement of your structure. And after about a month or two, it learns that, and you can set threshold values. I'd only like to be informed should this event occur, or it comes out of the threshold value. They're very heavy duty and rugged and weatherproof. We have installations in the coldest of British Columbia to Africa. We'd want to use this as an asset management tool because it provides early and continuous detection for your structures. You can know, you could be proactive rather than reactive to issues happening on your bridge. Certainly gives you more data for the inspectors to say, hey, we should focus on this area of the structure of the bridge when we go out next, whenever. Continuous, it's also very cost effective, much less than any fiber optic sensor system that's going to be out there. And it's a very flexible system. So you can use it over cellular connection, fiber optic, if you have that on the bridge, and for extremely remote locations, we can do satellite-based communication. One of the most important case studies that I think we did was a direct comparison with a fiber optic system. This was done with WSP and the Delaware River Turnpike Bridge, and they installed we came to them a little late in the process, and they were kind of blown away and said, why didn't we know about this? So they had already installed the fiber optic sensors, and out of interest, they did a side-by-side comparison with our product. These were the results of the comparison. So we actually provided more data. Rensys is the red, the blue is a fiber optic sensor. And so we reported more data more frequently. As you could see, there was a dropout in the fiber optic data, and Rensys continued to keep monitoring. SenseScope software is very user-friendly. You can take all of the data and interpret it any way you want. It's a very friendly user interface. So if you want to know what your structure was doing at this point last year or 5 years ago and compare the differences, you can do that. You can then view those results Typically, you view it like this, the first top left, but you can then view those results as a chart or a visual. So as I mentioned, the threshold-based alerts, this is just an example of what kind of an alert that you could get to your email. We could also have it sent to your mobile. It just gives you a heads up when the system is out of alignment or past that threshold. For structural applications, we can do bridge, piers, and abutments, monitor settling, instability, tilt. For the superstructures, strain, vertical displacement, deformation. We can monitor bearings and joints in every aspect, tilt, temperature, strain. We can monitor vibration and tension in cables. We can also monitor scour now. We have a specialty Scour Probe that's been in development for some time. We can perform live load testing, tell you when a live load vehicle is going over your bridge and actually take a picture of it. Lots of other structures, tunnels, cranes, buildings. It's an example of monitoring bridge bearings. In the bottom right, you'll see this is what a healthy bearing looks like. So you have temperature inverse to the bearing movement. As I said, we can do long-term live load testing, and we did this very successfully, inexpensively on the Robert Norris Bridge in Virginia. They were considering doing a repair and wanted to know where to best focus their assets and funds. So we put out several sensors on the structure, drove two 83,000-pound vehicles over, so they knew exactly how much and where their weakest points were, and they made the retrofit. Asset management for fracture critical monitoring. By the time you're seeing a fracture in your structure, it's essentially already too late. You're going to have to, the costs are much greater than the earlier that you can detect that weakness. For monitoring approach, we monitor typically strain, the bearings, and these are several structures that we've done. I-95, several structures in Maryland, I think about a dozen, the Robert Norris Bridge, and I-68 over Wills Creek. Here you'll see the two ways that we can monitor the vibration and tension on cables, or precast concrete tension monitoring. Another project that was very well discussed earlier in the week was the I40 Desoto Bridge. So on that structure, they found a critically broken beam or girder. It was a three-phase repair effort. We installed 42 strain monitoring sensors in less than 48 hours. And that gave them the ability to quicken the time for the repair and really know what was going on with their structure. It's kind of an inverse as to what we typically want to do. We want to monitor a healthy structure and fix it when it's starting to wane. For this project, we were actually able to monitor the structure at its worst and then monitor the repair and how effective that was. This is just a guide of where the sensors were placed throughout the structure. Another project that we did was the 2-year monitoring for the Midtown Tunnel in Norfolk, Virginia. They were having some concrete issues in their reinforced concrete sections. So we did pretty extensive work here for over 2 years. Here you'll see some micro crack meters, joint meters at the portals, at the immersion joints, biaxial tilt meters, air surface and profile temperatures. So each sensor also reports temperature in 1 degree Celsius increments. If you'd like something more specific, we have a sensor that's capable of doing that. You see the gateway set up right over here. They're receiving continuous data 24/7 every day. We're also working with the Colorado Statewide program to increase and structurally monitor their structures. Currently, we're doing retaining walls. We're monitoring tilt, strain, and scour is their next project coming up. We've been deployed on both wood and any other surface you can think of, and the sensors function just the same. One of the newest developments, or the developments that's been in progress for some time, is continuous monitoring of strain. So we have a suite of tools that allow us to do that, including an ultrasonic water level sensor, a wireless camera to see what's going on the site, if there's debris building up, and where the water level currently is, and Now we're also monitoring the tilt on the structure. Now we actually have a Scour Probe that's highly effective. It's completely solar, so you would set the solar panel above the water line somewhere right below the bridge. That then goes to the transmitter, which you would also place at a high level. And the Scour Probe here that you see, each one of these red dots or lines right here is an accelerometer. And that's going to detect, really, so if you buried it in the soil level and you want to know, where your scour is happening. If it's in the soil, it's not going to be moving. If it's out of the soil, the accelerometer is going to pick up the water flow, and you'll be able to say, okay, that's my water table. And it doesn't have to be just installed vertically. It can be installed laterally, as you see, tied through some rocks, bearings, or laterally through the soil. Texas DOT was having a major problem with barge impacts and collisions. Essentially, the barges were just banging off the piers and driving away. This obviously causes major problems for the stability of the structure, and we worked with them to develop a self-sufficient system to detect when these impacts happen and to be able to record who impacted them. For that, we use typically just a solar-powered camera and vibration and acceleration sensors. This would be the setup here. So you would have the cameras and your sensors placed here. So the first step that Texas DOT took was installing buffers so they didn't hit the piers. Instead, they were just slamming off the buffers. They approached us, and we came up with a solution. Every time they were hit, to take a photo, each barge has its own unique GPS identification tag. We clearly could say, you hit our bridge here, here's the fine. So this is one example of the impact. Here's another very larger impact. And the conclusion, it's a very cost-effective asset management system. We like to call it cheap insurance. You can monitor your worst structures for a long time for very inexpensive. You can monitor the critical components, members, bearings, piers. You just tell us, we'll work with your engineers to identify those points, and we can essentially monitor anything you want to for expected at least 20 years before somebody has to go out there. It's very much a plug-and-play system, and it's very flexible in what the user needs and wants. That's my presentation. So he asked if there were any solutions that we have for hitting, such as signs or just overhead structures, that you're not passing the minimum clearance. We can do that. Essentially, we would place a vibration or accelerometer on that structure and a camera right next to it. So anytime a sign or something was hit, you would get a warning or a notice. And we're actually discussing that exact solution with the Long Island Railroad. So the question was, what is our cloud provider? We use Amazon S3 enterprise servers. So the question was how temperature, can you repeat the question one more time? Temperature capabilities, implementing the temperature capabilities. We do. There was actually a new structure, a new bridge that was just built, and I won't say where, but they were having some serious problems with twist in the bridge, to the point that they were going to build a new bridge. We installed some sensors there, and it turned out the sun, when it rose in the morning, was actually torquing the bridge completely. And so when it set, it changed directions and torqued the other way. So they were able to identify that, cut a point, and release some tension in the structure, and for much less than building a new bridge. All right, well, thank you for your time. I appreciate it.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.